So welcome everyone to Ontology Summit 2020. Today is the 1st of April 2020, and the session today is the second synthesis session. And I will be giving a presentation which is labeled Synthesis 1. Sorry about that. It was intended to be a summary of the first synthesis session, but so I will give this presentation right now, and then actually during the presentation, hopefully, we'll begin the process of discussion to continue the synthesis process.
Kenneth?
Oh, are your slides online somewhere?
Yes, if you go to the meeting page, there's a link.
Yeah, it's hard to find things on that.
If somebody could put it on the chat, that would be helpful.
Kenneth?
Yeah.
One point to all of the participants, please shut off your video cameras to preserve bandwidth this time. Most times actually, but in particular this time, it's a challenge for the networks.
Yeah, there has been issues with the...
Well, the network usage is up greatly.
Yeah.
Thank you.
Okay, so so I'm sharing this presentation, but you can also download it and look at it.
Yeah, I can never find anything on that session page. It's got so much detail there, and the stuff you want is never highlighted. I can't find the...
It says slides, John.
The slides.
Just search for slides.
Search for slides. Yeah.
Okay, so that's a very brief presentation.
Can you hear me?
The intention is to open up for discussion rather than to...
I can't find slides. I can't find anything for slides.
Okay, so I'm going
to... Kenneth?
Yes.
I'm sorry to interrupt again. The slides that you're showing are listed on the meeting page under the section heading Agenda. Is that correct?
Yes.
Okay.
So I'm going to first talk about the theme. So that's just a review. Then what tracks we've had so far. And then we'll open and I'll start talking about the synthesis, which is emphasized what at the moment. So the theme is divided up into these question words. Whence, which means, in this case, the historical perspective. And then the who, where, when of use cases, which we have not actually started those in the summit. Then why? So this is a general big picture. I mean, why is this topic emerging? And how? So this gets us into more detail about how one actually develops, uses these knowledge graphs. And it's actually pretty widespread in its number of conferences and trainings. So we do have a number of sessions that have already been devoted to it, and there'll be more in the future. And then whither, so this emerging standards, research challenges, and speculation about the future will be coming up toward the end of the sessions. Okay, so here are the tracks that we've seen so far. Whence with John and Chaitanya. And then we had a why. Actually, this was Jan's back in the fall. And then Matthew West and upcoming Ernest Davis. in May. Then we had some 4 sessions so far on how, Anirudh Paco, Hari Sir Hari, Spencer Briner, and upcoming is Christoph Janovich. And there will be 1 or 2 more, not yet scheduled. Then use cases, we're going to be having 3, but then I hopefully will be at least 1 more. Then Wither, the plan is to have a couple of those, Vinay Chowdhury, and then another one. So some of the slots have not yet been firmly haven't been confirmed yet, but I have tentatively filled all of the slots. Okay, now synthesis. What's the progress here? There's been a nice discussion and development of basically what definitions of knowledge graph. Gary, Todd, and Ravi, and I will go on to summarize some of those in the next few slides. Other discussions are ongoing, but have not settled into the point where I could actually give a report on them. Hopefully, as the sessions continue, those other groups will continue their efforts. Okay, so synthesis. What is a knowledge graph? And what I've seen is that there are a number of points of view. So knowledge graph is like an elephant, and a whole lot of people are feeling different parts of it. And as a result, you get a variety of different definitions of what a knowledge graph is. So you could take a theory point of view. So look at it abstractly, mathematically. You could look at it from the point of view of the purpose of knowledge graphs, or the requirements of what a knowledge graph should do for you. Of course, there are many who've looked at the implementation of knowledge graphs and saw that as being the primary way to define what they are. Then you could look at it from practice, which we haven't looked at too much yet since use case track hasn't started. But hopefully we will be seeing a number of interesting use cases that will start to give us a better feeling for what use cases are in practice. And there could be still other points of view. So in looking at the different suggestions for definition, I think we should think about what point of view we're taking in proposing some definition. I think that would help in terms of organizing the diversity of points of view. So one suggestion is that knowledge graph is a model of a portion of a domain. Another, so that would be, so what would that be? Think of what the point of view is for that. Or it's a graph-based, flexible, formal knowledge, data and knowledge representation. So now that's definitely looking into the implementation aspect. It should easily map to other data formats using generic tools and pipelines for updates. So now you're looking at the purpose of a knowledge graph. Or perhaps that's requirements. Maybe requirements.
Hello.
Ravi? Are you having trouble with your audio? Okay. Okay, then, so another way to look at it is to look at knowledge and graph and see how putting those two together would give us a definition. So the first look at graph, of course, that's looking at it theoretically. There is an entire field devoted to it, but having been a mathematician myself and worked in the field of graph theory, I can tell you that this is not, it's not entirely accurate to say that it's a well-defined notion. There are at least as many kinds of graph in the field of graph theory as there are definitions of knowledge graph. So if you want to appeal to mathematics, then you really do have to start getting into the theoretical aspects and come up with a theoretical definition and treatment. So believe me, it can be really confusing. In fact, just the other day, someone was asking me, how was it that I proposed at one point to have a solution to the graph isomorphism problem? And I said, oh, well, you're using two different definitions of the word graph. Okay, the one most people use in the term graph for graph isomorphism is an unlabeled, undirected graph. When you start adding labels, directions, and all sorts of other machinery to your graph, then it's actually quite easy to solve the graph isomorphism problem. So you see, so even in that little discussion, you see how two different definitions of the word graph can lead to a completely different understanding of a major problem in the field. So what I've done actually is to develop such a treatment. I only just finished it and I'm submitting it for publication. And hopefully there'll be a chance for me to give a presentation about that so that we can start kind of really getting a theoretical understanding of what one means by a knowledge graph. Sorry about that. So second, consider the word knowledge. Of course, that's also not a well-defined notion. And there are a number of different English definitions. So this, I'm not sure, was this Gary or Todd who came up with this?
It was probably me.
Todd, okay.
Some random thoughts jotted down.
So I think they're valuable. It's important that we start the discussion about this. And as I said, as you discuss it, try to classify it according to the point of view that you're taking. Okay.
Well, wait, hold, Kenneth.
Yes.
What do you mean by the point of view I'm taking? Sorry to be picky, but at that point.
So it was in this slide 10.
Okay. Well, I put something in the chat. I realize you can't watch it right now, but these things are not independent.
No,
right?
certainly not.
Okay. Okay. So in particular, what you want to consider as knowledge is certainly going to be dependent on your purpose and and/or the requirements. And it also may be constrained by what you can have available for implementation. So
excellent. That's what I'm looking for here as you start looking at different definitions. Put in a statement like you just said.
But
that's
this is recorded, right? So I don't have to remember.
This is being recorded. You don't have to say that, but
I don't have to remember is the point at this
point.
But
this is what I'm looking for here.
Okay. Yeah.
So that we can make a little bit more reasonable definition.
Yeah, understood.
And I think that's what sort of hampered efforts to define what an ontology is. Everyone was trying to get a universal, totally accepted meaning of ontology, while everyone was giving different points of view.
Understood. I think.
I believe this is the last slide. So here's an attempt to distinguish graph databases, property graphs, and knowledge graphs. Todd, I think that's yours, right? Or was that Gary?
Which one? This stuff?
Last slide.
Oh, I think I posted this the other day. Yeah. I think I have references for all three of these descriptions, though I may have edited them a bit. Oh, Kenneth, one point I wanted to make earlier. I do hope that one of the goals of this summit is that we propose a more coherent notion of what a knowledge graph should be or may be.
That's exactly what I'm suggesting.
Thank you.
And what I'm suggesting is that we organize it around points of view.
Fair enough.
That
we can try.
Try to organize it around points of view so that we don't get into the, like I say, the same problem others have, where people use different points of view, and as a result, you end up with a mishmash of different definitions. So it kind of goes back to the summit on context. So the moment that you specify a real clear context, then definitions can be a lot easier to specify. Okay, so let's open it up for discussion. Try raising your hand or unmuting.
I raised my hand.
Okay, so Todd, you're first.
Okay, I guess my question is directed toward David Eddy. Again, David, I'm not sure what you're trying to get at with your question and your follow-up clarification.
Okay. My perspective is from operational systems.
Right. Okay.
Those are not models.
Sure they are.
No, they're not. Those
Why
are
not?
models are distant from operational systems. Models are imperfect, incomplete representation.
Hence a model. So I guess I would just differing over little things, I think. But in fact, what you can do if you have if your knowledge graph is based on an ontology, that can be part of your operational system directly.
But operational systems have not been built with ontologies in mind. So how do we?
Oh, that's not true. Unfortunately, I can't name examples.
Of course you can. We're paying for it. I'm a taxpayer. I know who's paying for it.
Yeah, well, sorry, you can't.
You want me to get the references? But anyway,
yeah.
Operational systems are not models. Models are incomplete representations of wished for. And as resources and attention and focus is pushed off to the side, what was intended is often left out.
Well, that last part I can certainly agree with. Thank you.
Good point.
Okay, the word model is creating confusion here.
Yes.
In Tarski's sense, a model is as precise and is the fundamentally precise version of what your theory is about. So a model is exact, precise, and it has every theory must have at least one model for which it's true. But the word model itself is so vague that for the moment, I'm sorry that I introduced the word model in my previous thing. And so what I'll do right now is retract it until I write more about it, because unless you talk about what kind of model you're discussing, whether it's a mental model, a data model, a Tarski style model, a plan for the future, a model of your hopes or fears or whatever, you create confusion. But the point is that the short answer is that a model is whatever your subject matter is about, and that model can be as precise as any version of logic, or it can be as vague as any kind of initial guess. So a model can be whatever you're talking about it can be as precise as you like or as vague as you like. And for the moment, I'll just retract the fact that I brought the word model in, and until I provide more references to say what models should be considered as, it might be better just to drop it because it has so many ambiguous interpretations.
Okay, Gary has his hand up.
Can you unmute me?
You're unmuted.
Okay, can you let me share my screen?
Absolutely. Go ahead.
All right. Right now it says it's been disabled. Let me try again. I still see a disabled sign, Ken.
Okay, here's a problem. Let me see. That's,
Well, I was going to show something I worked on. I can talk about it as we work through this problem. I took 2 pieces of action to sort of try to move.
try it again.
All right, I'll try it now. Oh, yes. All right, let me see if I can share that. Okay, are you seeing like 2 pages?
Yes.
Okay, so let me explain what I did. Actually, on the right side, general questions. I thought that for our communique and our synthesis as part leading to our communique, we would need sections on these basic general questions of, you know, what, why, how, whither, and so forth. And so on the right side, I just started on some of the general things I thought of and knew of. For example, on the why section here, again, it's leveraging some materials that's been published, such as Amit Sheff. I mentioned that he was supposed to be my co-organizer, co-champion, co-partner on this, but has been prevented from being able to do that. But some of his work was relevant. I also in here cited Niket Tandon, who we had speaking about common sense for deep learning. So that we're going to have a speaker, distinguished speaker on common sense. So I think we'll have a lot more on that. And so that's a start on some of the why and the how. I don't think we need to go through the details here. On the left side, I went back to the fact that we have a use case section for our communique. Usually that's, we have sessions and we write up the summaries of the sessions. In this case, we're writing up maybe summaries of the use case. So I took Paco Nathan, who I had as a speaker, talking about rich context as an example in part of a use case. And what I just wrote, what I have here is the beginning of extracting from his presentation and other material answers to the question, like what, in terms of this particular use case, what do we mean in terms of what's going on? Why are they using a knowledge graph? How are they using a knowledge graph, and so forth? So I just leave this here. I present this as something that we can move forward as we have more speakers. If people like this idea,
It's a little hard to read.
Oh, is it? Okay, well.
See if you can go to like full width.
Can you see it better now?
That's much better.
Yeah. So this was the one on the right side, the general questions. I didn't mean for us to spend our time trying to rewrite this or edit this or anything of that nature. I wanted to present the general ideas and see if people like the ideas. So this was talking about generally, you know, why KGs, knowledge graphs, how are they done? You know, for example, they leverage linked data, they leverage things that are out in unstructured data, they leverage things that are out in DBpedia, Wikipedia, and so forth as sources, but they use natural language processing to extract things and so forth. So that's just an example of some of the ideas. This is the blow up of the use case from rich context. A little bit about the project, what's going on with the project, why do you need this project, why KGs in this project, how are they doing it, and what are the challenges, and so forth. So that's the main idea. I can stop sharing now, I believe. What do people think about that idea?
I think the one thing that's Well, you do actually have this research problems, issues. I think you have challenges there.
Yeah,
That's good.
there now.
If you could add more challenges and issues.
Oh, this is just a start. In a sense, a beginning, a straw man, as it were, of an idea about how to approach some of the material for the communique. That's why I wanted to. So there's two parts.
Yeah, and that's
there are these
all
general answers to these questions, and then there are answers in the context of particular use cases, and that will be a fair amount of our communique.
Right. No, what I was saying was in the future, remember that we have to come up with issues. Communique has to be a call for
I talked
action.
about issues last time, so I didn't repeat those. I mean, some of the issues are, you know, like how do you purify, how do you improve the very dirty data that you're bringing in here? How do you harmonize ontologies, since multiple ontologies? I had a list of those. The OKN aspect of it, Open Knowledge Network aspect, which DARPA is featuring, or NSF is featuring, I mean, certainly has a number of challenges to it. So I think there's at least an outline of possible issues.
Great. Any other comments on this? I think it's a great start, Gary. Fantastic.
Gary?
Go ahead, Todd.
I'm sorry. Gary, will you be able to share those notes with us?
I absolutely can share the notes with you. I could paste pieces into the chat, but I think it's better to make it a Google Doc or something like that. Now, remember, this is a straw man.
Yeah.
And in part, I'm trying to recruit people to sort of work on some of these things.
Right.
Yeah,
Well,
so
hopefully.
make it a Google Doc.
Okay.
And then ask people to volunteer to join the effort. Okay, Gary, now Ravi has his hand up. See, Ravi.
Ravi may be having communications issues.
Yeah, it seems so.
Uh-oh, yeah. According to his identifier on the Zoom thingy, it doesn't show him as being muted or not muted. In fact, his little microphone symbol icon is gone. Or is he calling in from the 914 area code? Is that someone else?
I believe that's John.
Okay.
Doesn't look like Ravi's in at all.
Oh, well, I'm seeing his name listed, but
notice his phone is black, not red. So he's probably been kicked off the network. He's probably been dropped off the network.
yeah.
Yeah, I'm definitely not getting anything from him, even though he's not muted.
He's still in India, correct?
I presume so.
Yeah, I don't think there's too many fibers coming from that part of the world to the U.S. Or if there are, they're probably saturated.
Saturated.
Yeah. Ooh, thank you, Gary.
Hey, I have to disagree. We have no problem with connectivity to India.
Oh, really? Okay. Is that a particular location in India, Mark?
I don't know. We have 3 sites there. It's no problem. We're running 2,000 people. We're running full video too.
Oh, Robbie just put something in the chat. He is in India, but he's having trouble with his phone.
That is plausible.
Okay.
Okay, let's see. Janet, you had your hand up, but you took it down.
Not intentionally. Let's see. Well, okay. I think what David is getting at is, it gets back to what I was saying last week, that we need a sort of a common sense engineering perspective on this. That is, that getting back more to the 1970s perspective, where we have operational systems, we have models, we have theories. We're not as deeply immersed in the world of the theories and knowledge engineering and things like that, that we can't get find a common sense grounding of what we're doing. So both what David was saying and what Todd was saying, both correct.
Sorry, I think that's Robbie, maybe.
Hello.
Hi, Robbie.
Robbie, yes.
Sorry. Continue, Janet.
Okay. So I think that we need what David's speaking for, the common sense engineering perspective, and then Todd is taking a little more abstract a view. There are implicit theories, implicit models, implicit ontologies in everything. And that's interesting and useful. But then there's also just the operational world that is beyond the models. So I think we need, well, we'll keep coming up against this in various forms, but I don't know if that helped or clarified at all, but I think both Todd and David are correct, from different points of view. And they're both useful, and we'll need to articulate those in what we're doing. But let's see, the mathematical definition of graph isn't going to be authoritative, as you said, but I do like the fact that you started with graph, because I think that is the key to this enthusiasm that we're seeing, is that it's graph-centered. And so I think that we have, but from a common sense perspective, we have data structures, data management perspective on graphs. We have the conceptual theoretical graphs. We have the presentation graphs, where you can discover things about your data. And we have, those are the three key ones that are, let's see, I guess the last one that came out in what Jan said yesterday, and he had said this before in his presentation, I guess we've also seen it from others, is that the graph can be a learning system. So that the data structures, the conceptual theories, graphs, and the presentation interface can all work together in a learning system. If we can tolerate looseness in what we're doing here in juxtaposing these perspectives, I think from the common sense side, we have to tolerate the looseness. Getting to the mathematical graph definitions, as you're saying, Ken, I think will be very helpful, especially with the not the undirected graphs, but the undirected unlabeled graphs. But we're talking about directed labeled graphs, the sort of moving applied mathematical graph theory with directions and labels. That's the level of precision we want from the math. Anyway, a couple of random thoughts there.
Great, Janet. It's what you need to do, I guess, is just to try to put that into writing. I think it sounds like a real valuable contribution.
Yes, as I said, I've thought about this quite a bit. I haven't put anything into writing. I'd like to work with what Gary has and see how to add these ideas in there rather than writing them up as a chunk, maybe.
Okay, let's see. Getting back to Robbie, let's see.
Yes, can you hear me?
Now we've got you. Great.
Oh, sorry. There's a lot of problems with my phone. I cannot go to market and buy a new phone. I can't get out of my house.
Mm.
Hello?
Yeah, go ahead. Go ahead.
So I sent you a set of slides. I mean, essentially a document which describes what. If you think that is too much to now do, I certainly want to comment on that model versus implementation issue. Whatever is implemented has a underlying model, or at least a description and document that describes what is implemented. Many times you can reverse engineer the code on an implementation operational system and get the business rules that have been put in the code before it has become an operational system. And I have worked on dozens of these operational systems, which all have some kind of underlying documentation. That's it. That was for the operational systems. What I want to talk is on the what aspect of knowledge graph. Is it possible to show it, or should I talk on using my Word document?
I'm opening up your Word document right now.
Good.
Give me a moment.
Here we have been working together, especially Todd, myself, Gary, Ken, and starting with Janet and John's earlier comments about what is knowledge graph. And Todd has given a lot of these inputs. Ken, you have described one of the slides, graph database, property graph, and knowledge graphs. So there are different views of person having certain specialty, how to define the knowledge graph. And I think we should synthesize, hello?
Yes, you're still there.
We should synthesize the multiple views. So
I'm displaying
one
your.
of the views I hold.
I'm displaying your document,
is that
Robbie.
a generalized graph, if it is acted upon certain logical and query aspects that deal with relationships and a domain, can be converted into a knowledge graph or can be filtered into a knowledge graph. Then the industries have their own views of what knowledge graph means for them. Some limit it to enterprise, and some like Google go to the globe. Go to the globe. Can you still hear me?
Yes.
Okay. So we have tried to put together in those documents. Are you? Oh, you are able to show. Yes, yes.
I'm showing it. Can you tell me what you want?
A table that shows what Gary brought to us. It's called appendix, but it's a very small print. And in the end, we show what Janet showed and what one of our speakers, Aniruddha Prabhu, spoke and showed a graphic. This one, This is from Janet. The one below that is from Aniruddha Prabhu, as well as another URL. And then this to me is the best representation. Then of course I have a yellow background, but the one just above that requires 1 minute of your attention. You see, we are talking of NLP through text processing, talking of visuals and graphs, tables, spreadsheets, documents, and mails, and many other sources of data. We do something on the sources of data, and we are trying to arrive at certain results. So, data sources, ability through logic, and database models, and the three types of things that Todd mentioned, like graph database, and knowledge graphs, try to arrive at the expected results, which you see in a symbol in the knowledge graph down below. This is the best visual I have found. Kindly scroll down. There is a forum called Party, but before we go to that, kindly, when you have time, if can you think this is good enough to be put on the site, then that table that Gary has shown has many views of knowledge graphs, and it gives the references also. So at the end, I just quote one interesting thing I found on the website, which is called Pool Party. It's a forum and there are contributors there. That's a URL, and they also make their own pitch on enterprise knowledge graph. Their domain is their enterprise. So these were some of the thoughts put together by all of us mentioned in this paper. Any questions?
Well, first, Ravi,
Yes.
Pool Party is actually a business.
Can you repeat what you said?
Pool Party is actually a business. They have a product. They call it their semantic suite or something like that.
Yes.
It's not just.
And within that, they do a white paper.
Yeah.
And that is what I extracted couple of paragraphs.
Okay.
The paper is too long. What they are saying is knowledge graphs exist on top of databases. This is just a view of presenting. We are saying similarly. Actually, what I like is what John said at one time. The conceptual data models, the logical data models, these two at least are like ontologies, and they are the starting point for knowledge graphs. But there must be non-triples views of reaching a knowledge graph as well. Todd briefly mentions that as n-array systems too.
Well, in regard to that, Ravi, the point I was trying to make is, from my perspective and my experience, knowledge really comes from the relations among the entities.
Yes,
not just the entities themselves, as you might get from a taxonomy hierarchy, but what are the relations between them or among them? And there can be n-array type relations. Now, with unfortunately OWL, you're stuck with binary relations and really just a few types of binary relations. But it's the relations that are really important.
Yes, and the more the complexity of the relations, the frequency of occurrence of terms, the near neighborness of other related entities, bidirectional, single directional relationships. As we enrich these data models, we get a collection of what we call knowledge. Querying on that relationship, we come across results. If they are within the domain, then that collection is called knowledge. This
May I
is
change,
just one point of view.
Ravi, may I change the subject slightly?
Go ahead, please.
Okay, I'll take my hand down now. The following question was sort of prompted by Janet's earlier discussion. And what had occurred to me that I may be missing myself is what's important about a graph? Why is that so appealing? As John has pointed out, everything you can probably do with the current graphs that we use now for data persistence can be done with tables in a relational database. And in fact,
Yes.
For instance, if you're familiar with the triple store Parliament, that's built on top of a database. And I think Oracle does it too. So they build their triple stores on top of existing relational databases and do some stuff to make it work out. So what is it about a graph that's so appealing or that makes it of value?
It's the only thing that is appealing is what you prefer to look at. It's easier to view a graph if you have tables that are filled up with lots of data, then you want spreadsheets. But if you have tables that are mostly empty, then a graph is better. So it depends purely on how you want to present things to your users. And there's an infinite number of different ways that you use for different purposes.
Okay,
That's
understood.
all.
But so a graph, the visual presentation of information is one aspect. Is there something more that makes it conceptually more appealing?
Conceptually, they're identical.
Yes, as I wrote, I just wrote in the chat. Again, graph databases are a new approach to sparse data. In particular, the conceptual theoretical side, it's helpful to us to think in terms of graphs, and as Spencer was doing. Or as we think about taxonomies and hierarchies and lattices, it's convenient for us to think of things in terms of graphs. And then the visualization side, we have those three uses of graph that have synergized now, where we're going back and forth between saying you could, the data can come from any kind of database, but we can put it in a graph visualization, and we can use a conceptual theoretical graph to to improve it or to validate it or that kind of thing. So I think it's important to distinguish the database side, which has been a big innovative push here. Then we slide into thinking about those in terms of conceptual theoretical graphs and visualize them as graphs. So those three things are synergizing to make this whole field, a quantum leap from where we were before. Even though we had all of these elements, they're now supporting each other.
So Janet, would you agree with John that the visualization aspect is sort of a primary driver, or?
I think so, but
okay.
It's partly visualization in terms of looking at complex data and saying, wow, I can see the structure of that. The ability to visualize your data is important, but we also conceptualize things in terms of networks and taxonomies, and so those are again similar.
Well, can I add a point that the point is that for a mathematician, any systems that are isomorphic are identical. You don't even because any theorem you can prove about one, you can prove about the other, and they're identical. But when you're doing computation, you do have to consider storage and programming effort and efficiency for computation, so that for different kind of representations, if your data happens to be densely packed, the way, say, for example, in your bank, you have all the accounts and everything there, the tables are very densely packed, and so it's convenient to think about it and visualize it and program it in terms of operations that deal with tables. On the other hand, if you're dealing with ordinary language, the relationships that you have are very sparse, and so therefore it's more convenient to put it in a graph. And then if you're trying to write something down, it's more convenient to put in a linear string, and then what you need is parentheses and cross references, which you use with some kind of notation for parentheses and cross references. And you can take any kind of table, any kind of graph, and you can linearize it and send it over a linear transmission line. So the point is, the point is that you have to talk about visualization. That is how people think about it. Then you have to talk about the kind of operations that you do on it, and for different purposes, for storage purposes, for computational efficiency, you might prefer to use one kind of algorithm or another, depending on the kind of operations you want to use and how you want to work with it. So the idea is that you have to keep in mind that for logic and mathematics, you abstract away all of the details and you just have something that is a universal notation, and I call that a Tarski style model. But then you always have to look at how do you visualize it, how do you program it, how do you explain it to people you're talking to.
Coming from
Right, and for the
I
computation,
have a comment.
Can I say one sentence? For the computation, the matrix methods are the computer prefers the matrix methods for the computations, or at least so tables, graphs, and linear strings in language are the three representations that we're dealing with here, and they each have their pros and cons. Go ahead, Robbie.
So can I interject from a non-technical perspective with knowledge graphs? I agree a lot of it is what to do with visualization. When we visualize our knowledge, one of the first things we generally do is we draw webs of knowledge. In your early years of school, you draw those webs to really represent what do you know about this topic. You put it in the center, and then you draw the relationships, and in a sense you're already automatically at a young age drawing a non-technical knowledge graph. And so one of the issues when it comes to having things in tables is it's very one-to-one. So if you have multiple relationships that you want to show, you need multiple tables, and that can be hard for people to grasp what's going on there, especially if there is a lot of information within those tables. So I think the benefit of knowledge graphs and the benefit of these webs is that we're really representing things in a way that is natural for the way people think about it. And with the technology being able to build on that, I think it builds a bridge between the human and the computer in the way we think about knowledge.
That's good. Someone write that down.
Yes, one comment I want to make. Hello?
Yes, Ravi?
Yes, go ahead.
Yeah, is about the skills of the participating community. If they are mathematicians, they will understand the definition of a knowledge graph. Let's say what Ken described it in mathematical terms. or when John describes it in terms of first order logic. What a person like me, who is physicist by background but not very heavy in math, would like to see patterns, would like to see visual graphics, would like to see mental models depicted as visuals, and thereby seeing the relationships, frequencies, and clustering of data more visually.
Okay.
So depending on the expertise of the user, practitioner, or developer of knowledge graphs, their representation might be more graphical, more visual, would be preferred by some.
Well, actually,
Others would
just one
prefer
point.
to describe it as data models.
Well, just one
But
point.
kindly remember, in every case, a data point, we are trying to see how we get information that is useful. And what is useful information is knowledge.
I think we just lost Ravi again.
Oh no,
Oh, okay.
I just stopped to see if there is a comment.
Oh, one point I'd just like to make is that mathematicians are the most visual people you can imagine. Mathematicians love diagrams of all kinds. The point is that they are very flexible, and they can create new diagrams just at the drop of a hat. And if you want to see the most mathematical kinds of things imaginable, just look at Euclid and Feynman and other kinds of people. They're using diagrams all over the place, and as their primary means of representing the way they think, and the way they put it down in mathematical notation, that is always an after fact. They never think in mathematical notation except at the stage where they're actually putting it down on paper. They're thinking in terms of these diagrams. So mathematicians are extremely visual, and that's why they create so many different visualizations. But the point is that they think of them as all as different views of the same thing.
Yes, yes. Thank you, John.
Okay.
Feynman, by the way, was a great physicist cum mathematician.
Oh, yes. And one thing he made is a very important point, and says you don't really understand something unless you can explain it to an intelligent 10-year-old child. And if you can't explain it to an intelligent 10-year-old child, you don't understand it yourself.
Does that apply to super compact cardinals also, John?
It applies to everything. It applies to the most abstract theories of quantum mechanics or computer science that you can imagine. If you can't explain it to a 10-year-old child, an intelligent 10-year-old child, you don't really understand it yourself.
Okay, with that, I think we should adjourn since we've reached the end of the hour.
Just Ken, what you have on the screen,
can you hear me?
the yellow highlighted portion is what I think remains to be done. If you can scroll slightly up, it starts, but it ends here. We have to still analyze what speakers have said about knowledge graph. What is a knowledge graph? You have, in your presentation, you have included some names at least, but we have to expand in this document what is their view.
Yes, of course.
So that's all I list here. I didn't mean to delay you. Thank you.
Sorry, Ram.
Yeah, it's Ram here. Sorry, I've been trying to kind of do two things simultaneously here. Because we are in this COVID-19 virus issues right now. So trying to resolve that on one hand. So the thing is that this problem has been there. We've been discussing this for a long time, the notion of what a knowledge graph is and so on. So I think what point has been raised that in this particular communique, I think we need to represent perspectives, okay? Because no single definition, I don't think we can come up with a single definition at this stage, although I have my own view of what this is all about. But that doesn't mean that you agree with my view of what this is all about. And actually, John kind of mentioned something very interesting in terms of people think visually, but when they try to compute, they try to map it into some computational purpose. So that could be the thing. So if you talk about graph structures and things like that visually, you have a visual representation of those. And then when you want to do some computation of that, then you map that into an appropriate mathematical representation and do the computation. So there are a couple of levels of levels of looking at it. The whole notion of this knowledge graphs, that's my view. But from a communique perspective, I think we need to kind of synthesize somehow or other what people have been saying.
Hey, Ram, could you type those thoughts into the chat quickly?
Okay, I'll try to do that.
Okay, with
Very good
that,
comment.
we will adjourn today.